right, welcome back. Let's go ahead and look at the next set of examples. So before we talk about this next cheat rule here, I want us to look at this. A to the 5th power all over a cubed. So what does that mean, right? Well, a to the 5th means a times a times a times a times 8. Writing this out makes me so happy. And divided by a to the 3rd power, which is the same thing as a times a times a. Well, what do we notice? We have a divided by a, right? And a divided by a ends up being 1. We have a divided by a again, which ends up being 1. And then we have a divided by a one more time, which ends up being 1. And this is just 1 times 1 times 1, which is 1. And then we have a times a, which means the answer is a squared. Now, showing all this work makes me so happy, but let's talk about this cheat rule over here. If you see, it's called the quotient rule for exponents. And when we have 8 to the 5th over 8 to the 3rd, that is that quotient, which means division. So this is going to, we talked about multiplication, and so now we're talking about division, the quotient rule for exponents. And basically what this cheat rule says is that if we have the same bases, right, they're both a base A and they're being divided, that's the same thing as just having one base and going m, this exponent subtracted by this, m minus n. Well, let's go over here and see if that works. So if we have, let me go to light blue, a to the 5th all over a to the 3rd. Okay, these have the same base, so what that's saying is that's the same thing as subtracting the exponents would be 5 minus 3. You always do the exponent on top, subtracted by the one on the bottom, and that would end up being a 5 minus 3 is a squared. So there you have it. And we have the same answer right there. So this is the long way, this is the cheat rule way, but I want you to show this work. Okay, let's look at a few examples and see how this is applied. So here we have x to the 10th divided by x to the 4th. So they have the same base, so we're just going to use that quotient rule, that cheat rule, and have, let's go 10 minus 4, which ends up being x to the 6th power. All right, cool. Let's look at the next one. So we have the base 10. These both have, so it's 10 to the 8th divided by 10 squared. So since it's division, we can use that quotient rule, and then we just subtract the exponents, the one on top minus the number on the bottom. So we end up getting 8 minus 2, which is 10 to the 6th power. Perfect, perfect. Okay, let's look at this one. Ooh, this one's fun. We have a negative going on, we have some numbers, and then we have exponents with the base of the same base as w. So what I like to do is I like to do my negative first. So I have a positive divided by a negative. A positive divided by a negative is a negative, so my answer is going to be negative. And then we just have 63 divided by 7. I'm going to do the numbers second. 63 divided by 7 is 9. And then we have the quotient rule. So I'm just going to write w and 7 minus 5. And then we just simplify that. So we end up with negative 9. W, 7 minus 5 is 2. So there is our answer right there. Holy my goodness, this is a lot. So what do we have? We have the negatives. We have the numbers. So that's the negatives are one thing. The numbers are the second thing. We have some exponents with the base A, that's a third thing, and then we have exponents with the base B, which is a fourth thing. So this is kind of like a 4-step. I like to, when I see something like this that looks like a little bit more complicated than something like this, I like to just break it into steps and just think about that, just do one thing at a time. So first step, the negatives, because if I look at the whole thing, it can kind of get overwhelming, so I'm just going to break it into individual steps. So 4 steps. The first step is figuring out the sign. So we got a negative divided by a negative, which is going to be a positive, right? So our answer is going to be positive. We have, then the second thing would be looking at the numbers. So 32 divided by 8. Well, 32 divided by 8 is 4. Okay, then we're just going to do the quotient rule here. So A, base A, 4 minus 2. And then these have the same base B, and it's going to be 5 minus, there's nothing there, but there really is a 1, so it's going to be 5 minus 1. And then we just simplify. I wouldn't write positive 4. I'm just going to write 4. A to the 4 minus 2, which is 2, b to the 5 minus 1, which is 4. So there we have it. There's our answer. Awesome, awesome, awesome. So let's look at the next cheat rule. And what this says is if you have a fraction, a over b, and it's raised to the nth power, really what you do is you just, each individual thing gets raised to the nth power. So a divided by b is the same, raised to the nth power is the same thing as a raised to the nth power and b raised to the nth power. So let's look at a few examples. All right. So on the next page, page 5 of 15, okay, that's where I'm at. We're going to use, that's called, oh, I forgot to say, that's called the quotient power rule for exponents. Okay. Okay, so we basically have a fraction, and that fraction's being raised to the third power. So that means that 3 is raised to the third power, and also 4 is raised to the third power. And then we just simplify. So 3 to the third power is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So it's 27 over 4 to the third power. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So there is our answer. Okay, perfect. Let's go ahead and look at B. I'll change my color. So this we have a fraction, but this fraction has exponents. So this one's trying to be a little tricky. And it's all raised to the fourth power. So we just do the power rule here to each thing. So this is going to be this x to the third gets raised to the fourth power, which is just the same thing as doing that power rule, 4 times 3, all over. And the same thing happens with y, y to the 2 times 4. And then we just simplify, and we get x to the 3 times 4, which is 12, and y to the 2 times 4, which is 8. And notice we can't do, even though this is division, we can't do the quotient rule. Do you know why? We don't have the same bases. So this is an x and this is a y. They're not the same base, so we can't do the quotient rule. The same is true over here. 3 and 4, they don't have the same base, so you just kind of have to figure out what those numbers are. 3 to the third is 27, 4 to the third is 64. So that would be the answer there. Perfect. Let's go ahead and look at the next problem. So we have all of this, holy goodness, and it's all being raised to the second power. So really, if I was going to break this down, I have to raise this to the second power, this to the second power, and this to the second power. So this is really like a 3-step problem. R is my first step, S is my second step, and T is my last step. So 3 steps. Okay, so let's go ahead and do it. So it's basically just the power rule. So we're going to go R to the 2 times 2, S to the 3 times 2, all over T to the 4 times 2. And then we just simplify. R to the 2 times 2 is R to the 4th. S to the 3 times 2, which is 6, all over T. 4 times 2 is 8. And there is our final answer. And we can't do the quotient rule because none of these have the same base. So that would be it. So let's go ahead and look at worksheet number 3. Now worksheet number 3 is on page 11 of 15, and I just want to pick maybe 2 of these problems to do with you. So these couple on top, they're kind of more simpler. So I think I'm going to pick 2 from down here where it gets a little bit more complicated. I'm trying to pick a good one. I wish you guys could tell me what would be a good one to do. Let's see, how about 10 and 14? What do you think? Would those be good ones to do? Would that be good? I think so. Or should I do 10 and 13? What do you think? 10 and 13 or 10 and 14? I'll just do 10 and 14. Okay, let's go ahead and get started. So we have this right here, right? So all of this inside gets raised to the second power. So we have 3 to the second power. We have the power rule here, which is going to be x to the 3 times 2. All over, and then everything on the bottom gets raised to the second power. So 2 to the second power, y to the second power. Okay, so we have all that, so I'm just going to put that in parentheses. And then this over here is just 1 over x squared. Nothing really to do. It's not even raised to an exponent. I mean the exponent of 1, which does nothing. So I'm going to simplify this, okay? So we have 3 squared, which is 9. X to the 3 times 2, which is x to the 6th power. 2 squared, which is 4. And then y squared. And all of this is really just multiplied by 1 over x squared, right? So then I'm going to simplify it a little further. I'm going to rewrite this. I got x to the 6th power, y squared, and when it's times 1 over x squared, that really just means that the x squared gets multiplied on the bottom. Perfect. Okay, so now we're going to look at these numbers. Can we reduce 9 over 4? And the answer is no, we can't. If you could simplify these numbers, like if this was an 8 and it was 8 divided by 4, then we go 8 divided by 4 and just make it 2, right? But you can't simplify this, so you just leave it as 9 over 4. Okay, I have an x here and I have an x here, and they're divided by each other, so I can do the quotient rule. So the next thing I'm going to do is 9 over 4, and then x to the 6 minus 2. And then that y just stays on the bottom. And then finally, I end up with the answer, which is x 6 minus 2 is to the 4th power, y squared. So there's our answer. And remember, you can check your answers. This is worksheet, well, I'm pretty sure this is worksheet number 3. It doesn't say, but I'm pretty sure it's worksheet number 3 and number 10. So worksheet number 3, number 10, 9x to the 4th, so 9x to the 4th. And you have to check every detail, right? So you got to check the 9, x to the 4th, x to the 4th, divided by 4, 4, y squared, y squared. So don't just try to look at it really quick. Really look item by item to make sure that everything's correct. And if it's all correct, then you got it right. So, woohoo, got that one right. Okay, on to the next one, 14. Let's go ahead and look at that. So this is a little nice because all of this isn't raised to any exponent at all. So I can just kind of, I look and I see that there's some s's here and there's some t's there that have the same base. So I can do, and it's division, so I can do that quotient rule. So I'll just start off with that. So 2 to the s, and it's going to be 3 minus 1, right? There's no number there, which means there's a 1. And then t to the 3 minus 2. So that's pretty much it for that. And then what I notice over here is I have the quantity 3st, and all of that is raised to the 3rd power. So that means I have to raise 3 to the 3rd power, s to the 3rd power, and t. Everything inside there. So 3 to the 3rd power, s to the 3rd power, and t to the 3rd power. All over s squared t. I just rewrite that on the bottom. This isn't raised to the 3rd power. Only this is raised to the 3rd power. So this is just by itself. I just rewrite it. So I'm going to simplify all of this. And this becomes 2s to 3 minus 1 is s squared. And then t 3 minus 2 is 1, or just, I'm not going to write 1. It's just t. Okay. Times 3 cubed is 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3 is 27. And then what do I have over here? Ooh, I have the quotient rule, right? So I can go s to the 3 minus 2, and then t to the 3 minus 1. Okay, so then I'm just simplifying. I'm going to just use a different color to show the next step. So I'm going to do the numbers first. So 2 times 27. I'm not sure what that is. Let's do that. 2 times 7 is 14. Write the 4, carry the 1. 2 times 2 is 4 plus 1 is 5. So 54. And then I'm going to rewrite this. And what does this end up with? S to the 3 minus 2, which is, what is this? What did I write? Oh my gosh, you have to be so confused. I am so sorry. That is craziness. It's like, okay, let's just, you know, whiteout is a wonderful thing. Let's just say that. Okay, so 2 times 27 is 54. And then we just rewrite this, s squared nt. Okay, whew! That was very difficult for me, but we got through it. Okay, yeah. So then we go 3 minus 2, so we have an s here. And then t to the 3 minus 2 is 1, right? So you just don't write s to the first power, you just write s. And then t to the 3 minus 1 would be 2. So now we need to simplify this. What I see is there's a number and it's already simplified, so don't have to do anything with that number. We're just gonna rewrite it as 54. But I see that we have the same base s and it's multiplied, so that would be product rule, and then the same base t, and so that's product rule again. So s to the 2 plus there's nothing there, which means there's a 1 there, so we add it to 1. And then t to the there's nothing there, but yes there is, there's a 1. 1 plus 2, which means we end up with 54 s to the 3rd, t to the 3rd. And I just love these because what happens is we start with all of this mess, right? Look at how messy that looks. And we end up with this. Are you kidding me? This is like so simple compared to that. But we need to go ahead and check our answers. So this is worksheet 3. And this is problem 14, and so I want to make sure that I check the number, the s variable, and also the t variable. So what is this? Number 14, worksheet number 3, number 14. Okay, so 54, we have that. S cubed, we have that. T cubed, we have that. So boom, that is right. So that is it. Go ahead and finish this worksheet. When you get done, start working on the next video. All right, see you in a bit.